All right, let's take a look at this problem. So Tyler was at an amusement park. Yay! He walked at a steady pace from the ticket booth to the bumper cars. All right. All right. The point on the graph shows his arrival. Okay. I always like to write some information down here. I could use a different color. I'm gonna use this color right here. Arrival. Wow, that is a bright color. Arrival at the bumper cars. At the bumper cars. Okay. And what does the coordinates of the point tell us about the situation? Okay. So what this represents, remember, this is my x-coordinate, if you guys didn't know. I'm gonna use a different color because I got lots of colors here. That's my x-coordinate. Wow, that is bright. And that is my y-coordinate. Okay. And this x represents seconds. This represents seconds. And this y represents meters. Meters. Okay. I don't know if I should have chosen this one, but it's fine. Okay, so this means it took Tyler 40 seconds to travel 50 meters. Yep. To the bumper cars. Okay. So the table representing Tyler's blah blah blah. Complete the table. Okay. All right. So we're given this, right? I'm just gonna work with this one because I like it. So it's gonna be 50 over 40, 50 meters per 1 second, 40 seconds. And so I'm going to divide by 40 to get 1 second, right? Because I want to work with 1 second. So 50 divided by 40. 50 divided by 40 is 1.25. So that's going to equal to 1.25 meters over 1 second. So, or not 1 second. Yeah, that's 1 second. So it's 1.25 meters per 1 second. Next, plot the pairs of values on the grid. So I got 1 and 1.25, so that's going to be hard to do. I'm going to do 30 and 37.5 first. 30 and 37.5, that's about like right there. And then 20 to 25, that's like right there. And then 0, and then 1 and 1.25, so that's like 1 and 1.25. That's kind of hard to do. I'm guessing it's like something like that. Okay. All right, so I did that. What does the 0.00 mean in this situation? It just means Tyler, that was his beginning at the ticket booth. Tyler's time and distance from the ticket booth, because he was traveling right from the ticket booth all the way to the bumpers, right? So 00 means he hasn't moved, or he hasn't even started, right, traveling to the bumpers. So how far away from the ticket booth was Tyler after 1 second? And then we did that right there and labeled the coordinates. That coordinate, my friends, is 1 and 1.25. And what is a constant proportionality? The constant proportionality is 1.25, right? So 1.25 meters per 1 second is the constant of proportionality. What does it tell you about Tyler's walk? Where do you see it on the graph? So Tyler's walk, it just starts right at 00. Starts at 00, and he travels for a total of 40 seconds, right? 40 seconds. and he traveled the distance of 50 meters. Okay, that's pretty much it. And then where do you see it on the graph? I see it right here on the graph. Now, if you all want to see this happen, I'm going to see if I can draw a straight line from here to here. And voila. As you can see, that is my line. Ladies and gentlemen, that is my line for a proportion. Wow, that's kind of cool, right? How was it that I plotted these points and then somehow it made a straight line out of this? That is the power of constant proportionality. In fact, this line needs to end right here. It shouldn't have this long thing because he ends at 50 meters at 40 seconds, but that's what I have right there. Okay, so this is the power of a graph, right? Like, we've been looking at tables for a while now. Now we're taking a look at graphs as well. And by the way, graphs, tables, equations, they're all the same thing. They're all the ways to represent a real life scenario. So I hope that helps, and I'll see you guys in the next video. Bye.